I think omega-3 has the pharmacological profile, like it has the pharmacological potential, like to act like drugs, but it's the safety profile of a nutrient. So there's lots of omega-3 research going on. I'm now an associate at the Fatty Acid Research Institute, which is it's a nonprofit, but they do a lot of fatty acid research, and mostly omega-3. So I'm involved in a couple of studies there. But the founder of that, Dr. Bill Harris, he's amazing, and he's developed something called the omega-3 index test, which is a more accurate long-term marker of omega-3. So you measure omega-3 in red blood cells, which stay around for about 121 days. So it's like a long-term marker versus measuring it in your plasma phospholipids. The omega-3 index, he's just published one phenomenal study after another using the omega-3 index and on large cohorts of people, and has found that a higher omega-3 index, so this would be like 8%, which is not what's in the US. So the average omega-3 index in the US is like less than 5%. 5% of, the fatty acids being omega-3. So eating fish or supplementing with fish oil, which is, you can get a lot of omega-3s from doing that, versus both are good. The thing that's amazing with the omega-3 index is that people that have the 8% omega-3 index have a 5-year increased life expectancy compared to people that have 4%. 5-year. And there's studies showing that they're like, you're much less likely to get Alzheimer's disease if you have a high omega-3 index. So the quality of life is better as well. I think omega-3 has the pharmacological profile, like it has the pharmacological potential, like to act like drugs, but it's the safety profile of a nutrient. So people are so interested in aging drugs and metformin and this omega-3 stuff.
Yeah.
Oh no, 5-year increased life expectancy. It's preventing muscle disuse atrophy, and it's sensitizing. That omega-3 in the studies that were done, I should caveat this, the studies have been done in young people. They're going to be repeated in old people, but because they have to be sure, it's not ethical, because knowing how, just being bedridden for, a period of time is so devastating for a person. It's hard to do those studies.
Right.
So you have to really know that this might protect them before you do it. So most of the stuff's done in young people. Now there's other studies that have been done with omega-3s in combination with exercise in older people, and it does seem to improve muscle mass and strength. This is emerging data, but I think that it'll continue to emerge where it's sensitizing the muscle to amino acids, and it's doing it because your muscle cells, they're made of omega-3, and it's changing probably the way these omega-3s are transported. It's changing, a lot of things inside of it. So I'm really excited about that data, because it's like, for one, you can be more strategic.
The International Fish Oil Standards, IFSO, they have a website where they do third-party testing of a ton of different fish oil supplements from around the world. And they measure the concentration of the omega-3 fatty acids in the actual supplement, because nothing is ever what it says on the bottle. And then they also measure contaminants, so mercury, PCBs, dioxins, things that you'd find potentially in fish that are harmful to humans. And they also measure mercury and then oxidized fatty acids. So they measure that, and they give you a total oxidation number. It's called TOTOX. So kind of back to the why for fish oil, and I personally think it is one of the most powerful anti-inflammatory things, dietary lifestyle things that we can get relatively easily, that is going to powerfully modulate the way you think, the way you feel, and the way you age. And a variety of different types of studies kind of led me to that conclusion. A variety of, observational studies. So there's been lots of work by Dr. Bill Harris and his collaborators looking at what it's called the omega-3 index. So this is actually the omega-3 level in red blood cells. So red blood cells turn over about every 120 days. So it's It's a long-term marker of omega-3 status. This is very different from 99.9% of any study you see or any lab that you go to get your omega-3 levels tested. You're getting your plasma phospholipid levels tested, which is kind of like, you can think of it as, what did I eat a couple days before? Oh, I had fish. My omega-3 levels are great. But did you eat fish like that every week? Or was it like, was like you went out to dinner? So it's not a great biomarker for long-term omega-3 status. It's kind of like the fasting blood glucose levels versus the HbA1c, which is like a long-term marker, right, of your blood glucose levels. So the omega-3 index, he's done a variety of studies, observational studies. So for people listening, these are studies that are obviously flawed because they're not establishing causality. You're looking at people's lifestyles. But in the case of Bill Harris's work, he's measuring something. So he's measuring the omega-3 index, and he's measuring the omega-3 index in people and then looking at their mortality risk, for example, or their cardiovascular disease risk. And what he has found is that, first of all, standard American diet has omega-3 index of 5%. Japan, by contrast, has an omega-3 index of around 10 to 11%. Big difference there. And they also have about a 5-year increased life expectancy compared to people in the US. What he showed in his data was that and I think it was Framingham's study, where he looked at the omega-3 index in people that had a omega-3 index of 4% or lower, so close to what the standard American is, but a little bit lower. They had a 5-year decreased life expectancy compared to people that had an 8% omega-3 index. And so big difference there, right? 5 years life expectancy. But here's the really interesting thing. He also looked at smokers and their omega-3 levels. And so he stratified it, right? And he found smokers that had no omega-3 were like the worst of all. I mean, it was just like the worst, right? We all know smoking is bad for us and will take years off our life expectancy. But smokers that had the high level, like smokers that were taking their fish oil or eating fish or whatever it was they were doing to get them up to 8%, they had the same life expectancy as non-smokers with the low omega-3 index. But also, what's really interesting, and I was sort of on this trail years ago. I published a sort of integrative review on the role of the omega-3 DHA transporter MFSD2A in the brain. And what's really interesting is that animal studies, when you disrupt that transporter, it causes like 50%, breakdown of the blood-brain barrier, and like greater than 50% loss of omega-3 in the brain. So, in my opinion, it's that's animal evidence. Of course, there's human evidence where MFSD2A transporters decrease with age, particularly rapidly in Alzheimer's disease and with ApoE4. So there are genetic abnormalities and mutations that occur in that transporter where people have less of it, and they have microcephaly, so they have like smaller heads, and they also have cognitive dysfunction, sort of cognitive impairment, things like that as well. Some people have certain gene variants that actually they respond better to, for example, omega-3 supplementation, and others don't, where they would actually need a higher dose. And I think there's many more to be explored. Like, we haven't unlocked all of that yet. When I say we, I mean the scientific community, not me personally. I do, with the omega-3, and this again really hits home the preventative sort of role here that we can, have in our Alzheimer's disease risk. So with the MFSD2A, like these transporters are actually lost. So there's a type of cell called pericytes, per-E with an I, not to be confused with the parasite. They basically have these like big feet that wrap around the endothelial cells at the blood-brain barrier. And they serve really two main important functions. One is they're basically constricting and dilating and like helping squeeze like the flow of blood. So they're regulating blood flow to the brain, but they also are very important for that barrier. And they start to fall off with age, these pericytes, and inflammation plays a big role in that. But
the MFSD2A transporters are concentrated on those cells too, right? And so you'll see like hotspots of where the pericytes basically, once those pericytes start to fall off, that is when basically immune cells and everything starts going into the brain. It's like the start. It's like the start of the vicious inflammation cycle in the brain, of the leakage, amyloid accumulation, just everything downstream. And so there's something there with those transporters of omega-3 that are right at the same site, of where you lose those pericytes, which is also really interesting. And again, there's a lot of animal evidence that suggests the role of that transporter in blood-brain barrier integrity. Also, again, you can kind of like connect the dots here where you think, okay, well, this is a DHA, specifically it's DHA in phospholipid form transporter. So it's like, okay, there's got to be something here with the omega-3. And, I know there's a variety of scientists that are investigating this, but I'm sort of excited that I am now going to be part of a team. So I've joined the Fatty Acid Research Institute, which is Dr. Bill Harris's research institute, and as a research associate. And we've sort of secured a small grant to look at the role of omega-3 with blood-brain barrier integrity and biomarkers in people, a variety of different people that have small vessel disease, that perhaps go on to get Alzheimer's disease. And so I think there needs to be more research in this area, because the implications here, I think, are really important with omega-3 intake. There's two main lifestyle interventions, I think, that are important with respect to the blood-brain barrier. Three. So basically not getting or fixing your type 2 diabetes. And then the omega-3 intake, and like defining that will be sort of tricky. But, full stop, most people in the United States they're not eating enough fatty fish, and they're not supplementing with omega-3, which is sort of an alternative. And I think it was like a 2012 study out of Harvard that identified low omega-3 intake from fish, so the marine type of omega-3, not the plant ALA, as one of the top 6 preventable causes of death. They calculate, there's some, I'm not a biostatistician, but there was some calculation done with estimating the number of deaths caused by not getting in enough omega-3 each year. It was like the same number of deaths. It was like 84,000 deaths a year from low omega-3 intake from fish.